Dear students, now let me discuss about static friction. Okay, and so let me take the same example. Now if we put a very small force, okay, if you give a very small force F, okay, then you can find that the block will not be moving. Okay, so why the block is not moving if you give a very small force? Because the opposing force will arise automatically. When there is a tendency of relative motion between these two surfaces, then a force opposing to this relative motion F will arise, and that's why what will happen, and that's why the net force of this object will be 0. Okay, as there is, if you talk about Newton's law, in Newton's second law, then you can understand it easily. So if you talk about the equation of motion of this object, then obviously it will be summation fx is equal to 0. Summation fx is equal to 0. And what is summation fx? Summation f, capital F minus small f. Summation f is capital F minus small m, that means capital F is equal to small f. So this is only possible if the object is not moving, that means that capital F is equal to small f. That means the applied force is equal to frictional force. And that frictional force which will arise, that frictional force which will arise until the object will not move. Okay, till the object will not move. When the object will be moving, that will be the different case. So if the object will not moving and the opposing forces will arise due to these applied forces, then you can say this frictional force is the static frictional force, because this frictional forces arise in the state of static, in the static state of the object, or the rest state of the object. So you can say this F as a static frictional force. This F is a static frictional force. Static frictional force. Static frictional force. Okay. And now, if you now give more force, little bit of more force. Suppose this is 5 Newton. You can say suppose this is, or you can take little less. Suppose this is 1 Newton. Okay. So 1 Newton means if you give 1 Newton force to this mass m, and if the body will not move, then you can easily say that the frictional force that will arise will also be 1 Newton. That will also be 1 Newton. Okay. Now if you apply more and more force, okay, what will happen? If you take this experiment, if you give some more force, okay, this is 1 Newton force. Now if you give 2 Newton force, then this will also be 2 Newton. You can make this experiment easily. If you give now 3 Newton force, then this force will also be 3 Newton, obviously, if the object is not moving. If the object is not move, then you can say that this, if this is 3 Newton, this will also be 3 Newton. Now suppose if you give 4 Newton, then this will also be, if this will also be 4 Newton. If the object is not moving, then this will also be 4 Newton. Okay. So what this actually suggests? This suggests that the frictional force will be self-adjusting, but it will happen up to a particular value. You know, after a particular value, this mass will obviously move. Okay, but till that value, okay, till that value you can say that this frictional force is self-adjusting. So you can say that up to a certain limit, of applied force, up to a certain limit of applied force, you can say that the frictional force is F is self-adjusting. This is very important. And that certain limit of applied force, due to which, up to which the frictional force is self-adjusting. Suppose if you give here the 5 Newton force, okay, then this F will also be 5 Newton. But if you change further, suppose 5.000001 Newton, and then you can see, then if you see that the object is moving, then you can tell that this 5 Newton force, applied force, due to which 5 Newton frictional force will arise, this force is nothing but the limiting frictional force. So that certain limit is called limiting frictional force. This will call limiting frictional force. Okay, this is limiting frictional force. So the one state of the static frictional force, you can say limiting frictional force is nothing but a state of static frictional force, maximum value of static frictional force. So if you talk about the maximum value of static frictional force, that is F is equal to, if you talk about F maximum, and that is nothing but the limiting frictional force. And till now before limiting frictional force, the applied force will be same as the frictional force. But at limiting frictional force, what will happen? The limiting frictional force will now depend on the normal reaction like this. So if you talk about the normal reaction N and this is mg, then this limiting frictional force will be proportional to this normal reaction. And now if you take a constant to avoid this proportionality sign, it will be mu into n, and that is mu s, that is the coefficient of static friction. Okay, but here you can say that the n is equal to mg, but it is not necessary that always n is equal to mg. So the actual form of the limiting frictional force in terms of coefficient of static friction is nothing but Fl is equal to mu s into n. Okay, so this is now very important observation. Okay, thank you.